Good morning, everyone. I'm Lieutenant Colonel Jeremiah Sanders. I'm an Air Force material leader stationed here in Boston at Kessel Run, where I'm the Deputy Commander. I was chosen a few years ago out of the Pentagon. I was working as a program element monitor and came up here to inherit the Air Operations Center weapons system, an ACAT-1 program that was in the middle of its second critical change or program breach, had been going for 10 years and spent over $430 million and hadn't delivered anything to the field. And so it was quite a challenge to come and try to take over that program. And that's really a good starting point when you think about, if any of you heard Dr. Roper about 3 weeks ago at the AFA convention talking about a future where the B-21 takes off and then lands with different software than it took off with. How is that possible when I have a ground-based system like the Air Operations Center that I can't update in 10 years? Not just how is that possible, but why is the ability to affect change in software in operations in real time during a flight, why is that a strategic imperative? We're going to talk quite a bit about that, but back it up to the AOC. And so for many of you that may not know what an Air Operations Center is, an AOC is a geographically located command and control center. So with any of the geographic combatant commands, there is an Air Operations Center that is the hub of planning, executing, and assessing the air campaign within that theater. And it is, frankly, a hodgepodge of about 50 command and control and intel systems built from across the DoD, about 70% of them built by the Air Force, but then all of the other sister services have systems integrated into the AOC, the intelligence community as well. And then we have a lot of commercial off-the-shelf software applications integrated into, so we got about 50 C2 and Intel systems integrated into this comprehensive plan, execute, assess, replan system for the Joint Force Air Component Commander and his staff, which during major theater war can be in excess of 1,000 people in a single AOC. So when we took on this challenge of modernizing the AOC, none of the systems that were in it were intentionally built for the purpose of the AOC. They were built as other systems and then kind of kludged together. And our task, given an ACAT-1, was to modernize the whole AOC, and following the traditional DoD 5,000 defense acquisition system approach was build it all at once, a big bang replacement of that legacy system. The Air Force, our program office, had over the years asked a few times, can we take more bite-sized chunks, do increments or spirals of capability that would eventually deprecate out that legacy AOC 10.1 baseline? And the answer from Headquarters Air Force, from OSD, from the Defense Acquisition Executive was no, build it all at once. So that's what we inherited. And again, $430 million down in over 10 years, hadn't delivered anything. So when I got to the program office, I had about 150 people in the program office, another 230 people working for my prime contractor, and it was an organization that was very frustrated, not seeing the fruits of their labor. Everybody working hard, doing what they were trying to do, but morale was down because we hadn't delivered, and we were essentially in the middle of our second big failure. When you set apart a program, you are supposed to be able to get to a milestone C within 5 years. For AOC 10.2, that ACAT-1, it took 5 years just to get to a milestone B, to get all the services to agree on the requirements. And then 5 years later, there we were in a second critical change. So with that as a backdrop, we were fortunate in that, following the 5002 route, we replanned the program and said we need another 3 years and another $300 million just to get to that milestone C. Fortunately, Congress said, no, we're not going to fund you. And that crisis created the opportunity that broke that logjam we had of the bureaucracy, both within the Air Force and OSD, not letting us try something different. And the opportunity was that we got to go to Silicon Valley and find out how they work with software. And I'll admit, what I thought I was going to learn was the secret fairy dust that enables software companies like Lyft, Uber, Amazon, Google to move from stated requirements to something deployable, a finished system, a lot faster. So I was thinking in the frame of, I'm going to get from milestone B to milestone C faster. And I was not thinking big enough. I was wrong. When we look at the whole acquisition system, from defining requirements, building out a program plan, doing design, build, test, accredit, field, sustain of a finished widget, because it's done now, right? That system all has to change when it comes to software. And in fact, you need to take all those serialized functions and almost turn them on the side. You're going to do them all the time, and mostly in an automated way. So we'll talk more about that. That was something I was not prepared for. What I did know was that there were high-performing IT organizations out in the world, and I wanted to be one of them. What you see here is a rendering of information from an annually published report from the DevOps Research and Assessment Organization, or DORA. It's called the State of DevOps Report. And they do a scientific assessment of over 1,500 IT organizations worldwide on an annual basis. And they're able to ascertain who are the high-performing versus low-performing IT organizations based on these scientific survey results, and how much better are the high-performing IT organizations. You see that here, and you immediately dispel some of the rumors you hear about Agile, where Agile means you're going fast, but that must mean it's also insecure, or it must break a lot. No, high-performing IT organizations do go a lot faster, but they do so with more security, more quality, and they end up having fewer dollars spent on legacy system maintenance. They're more innovative, putting more of their resources into building the next best thing. And you can see also they get improved employee morale. When I contrast where we were 2.5 years ago, again, a program office that had worked for 10 years without delivering anything, to now where we are delivering new capabilities into ops, into the war fight, every 11 hours or so, the morale change is significantly different. And you can see, so for commercial industry, working in this way, becoming a high-performing IT organization is a business imperative. Look at the rate of change in just the Fortune 50 in the last 20 years. The upheaval that companies like Google, Apple, Lyft, Amazon have brought to that market, right? It's turned entire industries on its head. So commercial industry sees this way of working as a business imperative. For us in the DoD, this is a war-fighting imperative, because we have near-peer adversaries, or even not near-peer adversaries, that can inflict damage and impede upon our national security, because they're not hindered by our traditional acquisition system, and they're able to leverage ITs in ways that small startup companies can, and completely disrupt big markets. We have adversaries that could completely disrupt us. So that same organization, DORA, took it the next step. They're not just identifying who are the high-performing IT organizations, they were also to ascertain what are the specific attributes of high-performing IT organizations, and they are noted here. You see the 24 attributes of high-performing IT organizations. Most important among them is the ability to continuously deliver. What does that mean? It means that you do not have a stage gate from the point of building a line of code and putting it into ops or into production. So small, empowered software development teams of 8 people write code that could be a new feature, a bug fix, a cybersecurity update, a COTS package update, any of the above, and unilaterally have the ability to push that to their users downrange. That stands in stark contrast to the acquisition system where I have to build to suffice some requirements and have a requirement sell off by a test organization. You have developmental tests, you have operational tests, you have a certification process or accreditation process, and then we have layers of decision making for a milestone decision authority to say, yea, verily, your work in progress can move to the next stage gate and have a fielding decision. So we have to do all of those things, cover down on the equities that we would typically be doing in a serialized fashion. But again, we have an opportunity to automate a lot of that and to do it in a way that we limit the risks so that empowered software development teams of 8 people can do that on their own. How do we do that? So continuous delivery is the most important outcome and really was the first goal of Kessel Run. It almost didn't matter what software we were going to build. We had to set the conditions from a technology perspective and from a process perspective that we could achieve continuous delivery and then scale from 1 product team to 5 product teams to now we have on our Kessel Run platform across multiple classification levels, unclass, SIPR, RHEL 5i, Centrix K, JWix, soon to be SAP. We have over 40 individual product teams, both internal to our organization and external customers of our platform and CI/CD tooling that are now able to build and deliver software continuously. That was our biggest hurdle, and we'll talk more about how we achieved that underlying capability. But continuous delivery, you can see the 8 steps within that. Architecturally, we're going to talk about loose coupling, or what we call over here layered abstraction or disaggregation, having separations of concern between hardware and software, or even within software where you have commercial software, you have government software, you have safety of flight critical software, and you have electronic warfare software potentially on a platform. Where can we find and generate seams between those so there's a separation of concern and your update cadence, your release cadence, that continuous delivery flow is not driven by the lowest common denominator? It's important when we integrate modern systems with legacy systems. Some of our legacy IT systems, we're going to modernize them eventually, but they're stuck on an update cadence of every 12 or 24 months. I don't want to impede an ability of a software team who can release every day, waiting, and they have an interface with that legacy system. So we have ways to accommodate that. Again, using that principle. Product and process capabilities. Working in small batches is very important. We'll talk about lean principles. Also, lean management and monitoring. So it turns out the way that we traditionally manage well thought out programs, cost, schedule, performance to some succinct plan is not a management system or framework that is optimized for agility. And we'll talk more about that too. Lastly, cultural capabilities. You'll see I'm not in uniform today, and you all just had an opportunity to walk on our software development floor. What you saw was a mix of military, government, civilian, contractors, and a lot of different ranks. And when I have peer positions on our software development team, like a product manager and a designer or the engineer, I don't want rank to come into the decision space that has to happen in the natural tension among those competencies, right? So we take our uniforms off, and it's more of the air crew model, if you're familiar with that. Everybody has a job and a competency they bring to the table, and it's not about your rank in there. It's about your ideas and the equities that you're bringing to the discussion. But the command and control rigid structure that we see within the military and frankly, that we've kind of imposed upon our defense industrial base doesn't work well for Agile software development. And we'll talk more about that as well. All right, so the way that we should start to talk about program success, again, from a cost schedule performance perspective, we're measuring work in progress from one milestone to the next. And a program like my ACAT 1, which we thankfully canceled, went for 10 years, and you're just monitoring work in progress, cost schedule performance. We shouldn't be measuring programs that way, particularly if they involve software. We need to hold them to accountable for continuously delivering and generating value to our warfighters. So we went from creating no value to what you see here in terms of being able to create value. And we can start with a new building of a new capability and go from idea to working software on any of the aforementioned classification levels in about 4 months. And then as we iterate, we've taken our lead time for new capabilities down from many, many years to just a few days. The underpinning of that is how we've taken the accreditation process and really turned that on its head, so that we're still doing accreditation, but instead of accrediting every single individual software product, we have an accredited software development process. So if you pass the stage gates of that process, you inherit a continuous authority to operate. We've significantly ramped up our deployment frequency, and slide's a little out of date. We're getting faster, so we're down around 11 hours, every 11 hours pushing new capability into ops. That is achievable because we have a high degree of automation. I point that out over here, and I'll be saying that a lot. Automation is an underpinning of everything that we're able to do, because you need replication and repeatability of capabilities across multiple platforms or operational environments. And because we're changing our software baseline all of the time, you will build up tech debt and become very fragile if you don't automate tests around that software. You can see on the bottom there that we've automated out then the underlying infrastructure and platform, and use this concept of abstraction or disaggregation to have a separation of concerns between software developers who really just care about building their application, the functionality and their associated data. They don't have to worry so much about underlying compute anymore. And that was a big change for us, where traditionally our engineering task was, for every application that we are going to build out, we have to worry about driving in the number of virtual machines we need to spin up, right? So we remove contextually from the software development teams the responsibility of having to worry about underlying compute, so they can focus on the mission value that is their application. And what that results then is 70% or so of our developers' time spent on new feature delivery, which is a huge change. Traditionally, in most industries or legacy IT industries, only about 15 to 20% of developer time is spent on new capability. It's all the underlying baggage of a bad tech stack that takes up most of their time. All right, so our vision here, a vision is something that is aspirational. You probably never achieve it, but it's kind of the North Star that you're pointed at. We deliver combat capability that can sense and respond to conflict in any domain, anytime, anywhere. We set some organizational boundaries for ourselves at Kessel Run. We are a combat capability provider, C2 and Intel systems primarily. We don't do business systems here. There are other PEOs for that. So our starting point, again, being the Air Operations Center weapon system, targeting and GEOINT capabilities. And we've expanded to unit level command and control, unit level intelligence. That original portfolio has encompassed what was PEO, battle management, operational command and control, is now PEO digital Kessel Run, and has the same flavor of combat capabilities. But then we as we started to achieve the underlying infrastructure and platform success that enabled product teams to continuously deliver their applications, Dr. Roper said, hey, I want to leverage this platform and your CI/CD tooling and your continuous authority to operate and stand up software development teams to get after the biggest software problem in the DoD, the F-35 Alice, or logistics system. So we now have in our organization for a period of time teams that are building out those modern capabilities, and we'll talk more about how we've onboarded other customers to the platform as well. So our mission, continuously delivering war-winning software our warfighters love. So, foremost in our mission here, continuous delivery. I talked about the importance of that, so we put it right up front in our mission statement because we see that as the underpinning of true agility, and I'll talk more about why in a minute here. War-winning software, again, we're delivering combat capabilities, and software that our warfighters love. That's kind of a cushy kind of term for use in the DoD, right? Especially when we're talking about warfighting capabilities. But there is a huge missing competency among the DoD, software portfolios writ large in our defense industrial base, and that is user-centered design, or the practice of building based on iterative user feedback and conceptualizing ways from an empathetic research perspective that gives users something that is intuitive to use and that they love. Show of hands here in the room, who has a smartphone? You all do. You use the applications on your smartphone every day, right? Because they bring you value. You like to use them. And if one of the apps doesn't work well for you, you would use another one. Who in here would readily admit they're addicted to at least one application on their smartphone? Couldn't go through a day without looking at it. Come on, be honest. Almost everybody. All right. That is because there are companies that employ this competency of user-centered design to build value, to build intrigue, to bring the user experience to another level. And we want to do the same thing with our software. So a change in paradigm is coming where we traditionally would build our software in a vacuum, not talk to end users. We're kind of stuck building to a requirements document that was somebody wrote 8 or 9 years ago. And an engineer who never gets the context of the actual user builds a capability that checks the box in a black and white requirement. I'm done. And then we hand it over to the users and they go, I don't like it, or they don't know how to use it, and the software is just so bad that we have to send people to school to learn how to use the software. That's kind of the status quo for most of our systems in the DoD. And frankly, to the point where a lot of users, either they don't get the opportunity to go to school, or even then the software is just so kludgy they give up on it and they do their job with Microsoft Office products. That's the reality of how a lot of the air operations centers work today. And so we're trying to change that through that missing competency. And so we highlight it here because we do want to build software that our warfighters love, just like you all have that experience with your smartphones. I'll spend a little time on this slide because it's probably the most important. I mentioned earlier the thing that I truly did not understand was the significant amount of change that would come from achieving agility, and it is not something that happens between milestone B and milestone C. Who here is familiar with this? Almost everybody, okay, right? So this is the traditional defense acquisition system, lovingly called the horse blanket, and it's coupled with really 3 built-in systems. Our budgeting system down here, our defense acquisition system and the various milestones that we have to go through, and the requirements system. And what you see here is a representation of serialized workflow with decision points, and ultimately both vertically and horizontally this system is geared to have the the check marks from about 40 different stakeholder groups before you can move to the next stage gate. And those different stakeholders are biased to always start with no. So moving work through this system is really a huge task of building relationships and kissing the ring one at a time across about 40 different stakeholder groups, particularly as you have an ACAT 1. Before you can actually get to see the ultimate decision maker that says, yea, verily, you can move to the next stage gate, who for an ACAT 1 might be the defense acquisition executive. You go through those 40 layers and you're ready, and it takes you 6 months just to get through that bureaucracy to get to the decision maker. And we like to call ourselves program managers. I'm an ACAT 1 program manager. We actually don't get to manage anything. You're a process manager is what you are. The decision makers are far removed from the program managers. So we need to turn that on its head, frankly. This way of work, we're all about process and moving from one stage gate to the next. So we're measuring work in progress. How do we do that? Cost, schedule, performance. We lay out a plan. We define what we're going to build. We lay out the plan. We build a cost estimate that says it's going to take X millions of dollars to build this system in 5 years or whatever it is. And we're measuring work in progress. We are very process oriented, and we're oriented around the acquisition outputs, moving work from one stage gate to the next. We're not delivering anything, so we're not about outcomes. We're about process and outputs. This way of work is optimized for certainty and stability. Certainty in that we know when we start exactly what we need to build, and stability in that the world around us is not going to change while we're building it. Are either of those conditions true for an ecosystem of software that our products end up living in? No. Right? The answer is obvious. So we need a way of work that is optimized for change. The cybersecurity environment that our software is going to live in is changing all the time. Our software typically does not work in isolation, particularly if it's a C2 or Intel system. It's plugged into other C2 and Intel systems, right? They're all changing all the time. The way, as we move across a spectrum, and I draw it like this purposely, it is a spectrum of stability and certainty on this end. And if you're laying the keel of a ship that's going to go in the water, it's a thermodynamics and physics problem, and you can engineer out a solution, and the environment that you're going to end up in isn't going to change. So this is still a valid way of work when you have a high degree of certainty and stability. When you work on control system software, embedded software systems that is not user-facing but controls the hardware, that's somewhere in the middle. But on the far extreme over here is user-facing software. Users change the way that they work all of the time. As the threat environment changes, as a warfight changes, if it's a commercial product, people's needs and wants change. You have to be optimized for a high degree of change and uncertainty over here. And we need a way of working that allows us to build a little bit, put the capability out there, see how we've impacted the world, and adjust fire. And we want to build, measure, learn as fast as possible. So we focus on this build, measure, learn loop, and driving that down stands in stark contrast to a serialized work in process system. Right? So this is the way we have to work on this end of the spectrum when you are in a highly changing and uncertain environment. As you do that, optimizing for change, you care much less about process and outputs, and you're caring about the capability that you are delivering and the outcomes, the value that you are creating. And because you are learning as you go, you have the opportunity to reprioritize your work. So the decision-making process about how you allocate your work activities becomes very dynamic and needs to be. So we set acquisition program baselines that are intended to last for years. in this way of work. We defined a cost, schedule, performance, and that's what I'm going to hold you accountable to. That's your baseline. Go forth and come back in 5 years when you're done, right? That's this way of work. We need an ability to completely change our minds all of the time. Short of having this environment, I'm going to highlight why this way of working has not been achieving the outcomes we want to see. Almost all federal IT programs over $10 million end up over cost, over schedule, or deliver broken, and about 40%, like my ACAT one, never deliver. That's billions and billions of dollars of waste. I'll also highlight 3 books here that I highly recommend as kind of the recipe books for organizational transformation and the process know-how for becoming agile. The books Accelerate, which those 24 attributes of high-performing IT organizations came from earlier, Lean Enterprise, and The Startup Way. They have guided just about everything that we've done here at Kessel Run in the last 2 years. And some of the stats that show up here came from those books, some of the studies that I found in there. So almost worse than the fact that a high percentage of our programs end up over cost, over schedule, or broken is that when we do make it through this way of work, again, sheltered from actual feedback from end users, and we deliver the finished product, most of the capability that we field is actually useless to the end user. Over 2/3 when you're replacing a legacy system, and over 90% when we're building something for the first time. 40% of time and resources spent on program planning is completely useless. So that's essentially the whole first half of this chart. 25% of DoD acquisitions funds are spent on process compliance and reporting. So think about, in a typical government program office, almost everybody in the program office's job is to monitor the work in progress of your contractor, right? You don't actually do any real work, you're watching other people's work. So there's a lot of waste, frankly, involved in doing that. And then we have a bunch of legacy capabilities out in the field that are costing us most of our resources, and most of it is useless code. So as we start to think about doing things different, I often turn to these outcomes from the traditional acquisition process when people start to balk at changing the way that they work or thinking about changing the way that they work. This is the status quo, and it cannot remain that way. Unfortunately, though, as we've looked at organizations that have tried to implement Agile, some form of Agile framework, be it Scrum, extreme programming like we do here, or SAFe, scaled Agile framework, any of those frameworks fundamentally still rely on the ability to continuously deliver. But when we insert them into what the program office typically has ownership of, it results in a broken system like this, where organizations in the DoD are still beholden to requirements documents and program plans and budgets that were defined years ago. They start iterating, doing their sprints or whatever, and they have to put the capability on the shelf. Why? Well, because we haven't gone to test and we don't have accreditation, so we can't field it. So putting your iterations on the shelf, working in small batches between milestones B and C, is not Agile. Remember, and I don't highlight this to poke fun at. I'm just saying we have to be real with ourselves, and if collectively in the DoD we want to achieve the high-performing IT organization results that we saw on the third chart, we have to do those things. Continuous delivery, not this. So we call this water scrum fall, faux Agile, Wagile, pick your term. But now when you all see it, you know that it's not real Agile, and your response should be something like this. You can go ahead and laugh. All right, so really what we want to achieve is something that looks like this. This is the standard acquisition process that we'll just say these are years, right? So no value created for the end user until year 4. All right? Contrast with if the problem set is I got to get from A to B, well, I can't give the race car on day 1, but I have an easy solution that can start having an impact on that problem set of going from A to B. So we deliver something, we learn that our user doesn't have very good balance, so we give him a handle so he doesn't fall down, and we iterate, and we get better. And our user here is happier than this user because this user actually likes the wind in his hair, and the requirements document didn't tell us that. So this power of iteration, it delivers value through the process. It's really never done, frankly, and the underpinning of it is build, measure, learn. Another important aspect on this risk chart, and we can talk about it on this risk chart over here, is this is the risk profile of a typical DoD 5000 acquisition program. Cost, schedule, performance. I'm on my plan. Everything's good, right? Actually, no. You're building up risk all of the time until you actually deliver. And how do those risks come to fruition, or when do those risks typically come to fruition? Our test organizations in the room know this very well. Some engineers built a system in isolation for a couple of years and then they bring it to test, and what happens? If it's software that has to integrate with other pieces of software in an ecosystem or system of systems, there are functional and integration complexities that didn't work out, right? So you get a bunch of deficiency reports based on that. You have not kept up with the cyber rate of change while you were building in a vacuum for a couple of years. So you have a bunch of cyber Cat 1 vulnerabilities as well. And then lastly, both the test community and any users that come in to bang away on your system say, I don't like it. It's not usable to me. It's not operationally effective. So this happens in DT, and in our AOC 10.2 ACAT 1, this happened to us. We were 3 years into building a system, went to DT and never got out of DT. And the underlying hardware, COTS, software, and other C2 and Intel systems that we had integrated into that 10.2 system that we were testing had all been changing while we were in EMD between milestone B and C, so that we essentially had to do a sustainment update in the middle of development. And we had to rebaseline everything. That was going to take us a whole year, right? So this is the risk profile. Even when you think everything is fine and you're on your acquisition program baseline, unless you are delivering, you are building up these risks all the time, and then they come to fruition when you try to field. So we need to work in a way that is build, measure, learn, and I'm deploying all the time, so my risk accumulation gets burnt back down continuously. And the sawtooth here, the frequency of the sawtooth is how fast are you delivering, which is why we care about continuous delivery and measure how fast that we can go. All right, so let's talk about the problem set of building something like a whole air operations center, and I'll make it akin to the Great Pyramid, right? So our typical acquisition process, again, starts with requirements definition, doing an analysis of alternatives, having a program plan, cost estimate, and a budgeting process that lays out for the next 5 years, you're going to get $500 million, and we get an acquisition decision memorandum so we can have a milestone B and start designing stuff. For AOC 10.2, that was 5 years just to get to that point. And there was already a couple hundred people working on it. So again, this is essentially all just program planning. We actually haven't done any work yet. We had a capabilities development document, the requirements document, had 230 pages in that CDD, 2,000 individual requirements. The government handed those to engineers, and the engineers said, I don't understand what to build. So the government took almost another year and wrote out what we call mission threads, or the operational scenarios behind those requirements. So we had 16 mission thread documents to define things like deliberate targeting and dynamic targeting and mission planning and personnel recovery, these mission sets that have to be done in an air operations center. Each one of those documents was about 100 pages. So cumulatively here we're talking 2,000 requirements and over 2,000 pages of explanatory information on what needs to be built. 2 years of design, and then we actually start building. And so what we'll show here in terms of building the pyramid is your first task is it even feasible to integrate all of these C2 and Intel systems? Eventually, I think I'm at a usable state, so I go to developmental test, right? And that's where you realize those risks we talked about. Hopefully, though, you climb to the pinnacle of this pyramid. You want to have a useful system. That is where you're going to operational test. And then that last piece of creating software that our warfighters love or providing a joyful experience for our users, really we just don't achieve that in the DoD, frankly, most of the time, right? So that is the nirvana that we wish we could achieve, and for AOC 10.2, we were 10 years in, $430 million, right here in the middle of this process, never got to a milestone C, never got to field anything, and we canceled the program. So when I look at it over here, I'll go ahead and build this out. Feasible, usable, useful, joyful. How can we climb this pyramid or build the pyramid, but do it in a different way? Rather than defining the entire pyramid up front and building the whole foundation first and building up, what we want to do is narrow in on the worst problem set. If there's 2,000 requirements for an air operations center, somewhere in here amongst the hundreds of workflows that are involved in producing the products that come out of an air operations center, primarily an air tasking order and an airspace control order, somewhere in those hundreds of workflows and hundreds of humans that are doing their job is a problem that is so inefficient that it would be the highest priority thing to work on. So that's what we want to focus on. And rather than build the whole pyramid at once, we want to take a very small slice. Solve one user's problem, give them a joyful experience, and then move on to the next most important thing. So we're creating small slices of capability. We're not even defining an end state. I don't need to, because frankly, this notion that in traditional acquisitions at milestone C, the system is done, right? From here, all that's left is field it and sustain it. It is done. That is a non sequitur with the world of software. Software is never done. All right? So we have to get out of that mindset and create small slices of capability, and we just keep going. The way that we do that involves 3 primary competencies. So let's talk about these competencies for a minute. The first one I've hinted at is called lean startup. So it's lean principles. You should all be familiar with if you study Toyota production system at all. So limit work in progress, work in small batches, and who's read The Goal by Eli Goldratt, the book on the theory of constraints, so right? It's the proverbial whack-a-mole of process improvement. Find the most inefficient thing, fix that, and move on to the next most inefficient thing, right? So these lean principles, when the founder of the Toyota production system saw the opportunity that abounded from marrying that system to an entrepreneurial management framework, he said, this is what we've been missing. We got very good at quality in a manufacturing process, but not so much on understanding what exactly we needed to build and where we could create the most value for our customers. So entrepreneurial management frameworks replace the Tayloristic-driven general management frameworks that we typically employ and that all of us program managers are accustomed to or have learned. So not cost, schedule, performance, not deterministic program plans, but an entrepreneurial management framework that is optimized for uncertainty and change, because this is the world that we live in. So I need to build, measure, learn, prioritize value creation, avoid cost of delay. That's probably a new term for most of you, but if you read the book The Startup Way that I mentioned earlier, you're going to learn all about cost of delay. So let me take a minute and explain what that is, because it underpins a very important way that we have to think about requirements in the future. And that goes for the entirety of a portfolio, like building out a whole AOC. And it also should be, you know, the way that AFWIC, in our case in the Air Force, drives capability sets across the Air Force. We should be thinking in terms of cost of delay. On individual product teams or application development teams, they prioritize work based on cost of delay. So, if you're familiar with the shipping company Maersk, they're a multi-billion-dollar shipping company that has the big container ships that go worldwide. So, they had their own version of an AOC 10.2 problem set. They wanted to modernize an IT system that they use for planning out the shipment of goods across the entire globe. And what they were able to, so this baseline of capability that they needed to build, they had a requirements documented, and it had 70 main feature sets in that software baseline. And they had a 3-year schedule and several $100 million to build it. So then they did a cost analysis. They were able to ascertain, of those 70 features, what is the number one feature that is really kicking our butt from a business perspective today, that has the biggest business inefficiency? And they were able to calculate a dollars and cents value to not having that first capability in operations in their business. And the cost was $2.8 million per day. The next one down was about 2.4, 2, and then it really just tailed off to the other 70 features, or 65 features, essentially worthless. One-off scenarios that you'll probably need to do every once in a while, but not very often. And so, let me hit it here. That is the actual curve from the Maersk study. You can see those 3 most important features. So, we have this notion of should cost within the DoD right now, or it's really about cost avoidance, recouping cost where we can. We need to prioritize our work by where we can recoup the most cost. So for Maersk, that was 2.8 million, 2.4, 2.0 over a 3-year schedule. That's billions of dollars. For us in the DoD, in some cases, it is dollars and cents. So the first application out of Kessel Run was a tanker planning tool that enabled warfighters to go from a literal whiteboard of aerial refueling, the planning of aerial refueling within CENTCOM. It went from a whiteboard to working software in 4 months. And the efficiency gain from that software meant that there was 1 less tanker needed in absent per day. That saved $214,000 of fuel every day. So about $6.5 million a month. So there is a real dollars in cost savings. So that first app that we built, $6.5 million per month. We iterated on that. Again, finding the next most important thing. If this was the minimal set of capabilities, we started working in this fashion on that tanker planning application. And we iterated on the software product, build, measure, learn, in ops about another 30 times in the next year and doubled the initial gains. Okay, so that's one example of cost of delay. If we had taken the tanker planning tool through the serialized acquisition process of requirements generation, build it all, get 2/3 of it wrong and put it in the field 4 years from now, that would be hundreds of millions of dollars of lost fuel savings, right? So we can think of cost of delay in other ways, though, within the DoD. Lethality. So if I have workflows that are involved in the allocation of targeting, dropping bombs, and right now those processes might be error prone from a human error perspective, or just very inefficient and manual, overall my lethality is degraded. So we built a targeting capability in AFCENT that in one case reduced the time it took to plan a deliberate target, like a structure that we want to target, reduced that planning time cycle down by 85%, saved 9 hours of work per target. So now with the same number of targeteers in the AOC, I can plan for a lot more targets. Similarly, on the dynamic targeting side of the house, this is somebody pops up day of and we decide we need to target that person or that thing. A tank rolls out and all of a sudden there it is, we need to engage it. Our ability to do that was very error prone and manual. There were 66 opportunities for human error in that workflow process, and over a dozen times our targeteers were fat fingering target coordinates. There's a lot of opportunity for dropping bombs in the wrong place, and sometimes we would. And then there was no audit trail to understand how we had messed it up. So we built a capability in 4 months that removed about half of the opportunities for human error in just 4 months. Right? So no intent to retire all of the legacy system all at once. You don't have to solve world hunger. You focus in on the minimum amount of work that you can do to create value, produce that value in operations, and then move this way. You do that at both the application layer perspective and across entire portfolios. If I had another software development team of 8 people, should I have them work on a targeting problem or a mission planning problem? Which one is creating the most operational inefficiency right now? So we can think about lethality, human capacity waste. Again, on the tanker planning solution problem, we had about 5 to 6 people 8 hours a day doing that job, and in 4 months we were able to drop that down to 2 people and 2 hours, right? So we freed up human capacity to do other things. The elimination of human error we talked about. Cybersecurity risk. If I have legacy systems today with a lot of cybersecurity vulnerabilities, why plan out an iteration that might take me 2 years to fix all the vulnerabilities, where I might be able to fix the most important 1 or 5 in 2 months, and then just improve more gradually from a cybersecurity perspective. Acquisition process waste. I don't have to belabor $10 years and $500 million of waste in the wrong direction, right? That's a hard lesson learned. Okay, so the next big competency, apart from lean startup, let me back up because I kind of diverted at cost of delay. So user feedback, again, we're build, measure, learning in ops. So I'm not beholden to a requirements document that is written a decade ago. I use that to inform more as a hypothesis about what we might need to build. But if we learn something based on actual user feedback in operations that stands in contrast to a requirement, why would I be beholden to the requirement? That's not smart business. So we value user feedback, validating what we have built over the requirements. An ability to dynamically reallocate resources, again, based on what we learn. And your mindset or the framework of management shifts from building of a widget or product to allocation of capacity. Because I'm not going to build some in-state finished product. I'll never be done. Now we need to start thinking in terms of what we are acquiring is a software factory and an ability to continuously deliver software, not individual software widgets. So this way of working requires a different way of thinking about budgeting, which is more driven to capacity or level of effort. So innovation accounting methods that come out of the entrepreneurial management world. Who here has watched Shark Tank? Probably most of you, right? So the concept of, if you went into the Shark panel and you said, hey, I have this great idea for building an AOC, it's going to take me $500 million and I'll be done in 10 years. The sharks will go, I'm out, right? What if I said, I have an idea of how I could fix one problem for a user that's out there. I need $500,000 in 3 months. Okay, I'm interested. And the return on that investment could be huge. The sharks might bite, right? This is the concept we need that meters funding according to actual proven value, right? So we're not asking Congress and our taxpayers to buy into billion-dollar 5-year plans anymore. We're asking them to give us a little bit of money to create value, and if you like what you see, buy some more. So this is a different way of working. Growth boards is essentially like the Shark Tank venue, where as you think of a venture capitalist model of startup, where you get your initial inject of funding, and then you come back and say, I did good things with that initial inject of funding and I need more. This is a growth board model that says you are holding that team accountable to value creation before you keep giving them more money. So this is a different way of work, lean startup. The next big competency, user-centered design, because a user interface is like a joke. If you have to explain it, it's not that good, right? User-centered design uses concepts of user experience or design thinking, and we value the opportunity to understand empathetically the use case or problem set or pain points, we call them, of our users, but conceptualize ways of solving those pain points in a way that is not user driven. So our designers don't go ask, what do you want me to build? They ask lines of questioning that result in understanding, what are you having problems with? Then they can conceptualize a way to solve that pain. That the siloed mentality of a user who has only ever done one way will probably not think outside the box enough to come up with an optimal solution. So user-centered design is a little different than user-driven. Again, using empathetic ops research, and it is an iterative process. This stands in contrast to the traditional requirements process. Again, for AOC 10.2, it was 5 years of building 2,000 pages of documentation about what we needed to build. We write very little documentation about what we're going to build because quite often we will learn something that means we need to change what we're building. So all of that time documenting is, well, we saw the stats, 40% of it is wasted. So it is an iterative process. As we're build, measure, learning, the designers are thinking about building out the next set of capabilities in a prioritized way that are going to generate real value in a meaningful way. The next big competency then is how we engineer for change. And so we'll talk about metrics here. We have this concept overarching all of the work that we do called the one metric that matters. And for any given software team, there's really one reason that they exist, and it is to achieve value in some specific mission or operational thread, and then we want to measure them creating that value. So the one metric that matters is, what is the operational or business value you are creating? And if you're not creating value, why would I continue investing? So we don't just, we are focused ultimately on the warfight, the consumer or user, and the value we are creating. But we also care about the process efficacy. We want to be able to go fast. We've talked about the importance of continuous delivery and this build, measure, learn loop. We want to be doing it very fast. So we want to measure the speed of our process, but also the quality. The same study that the study group we mentioned earlier, Dora, in that same book, Accelerate, highlighted these 4 metrics of software delivery performance that are key to delivering that high-performing IT organization outcomes, right? So measuring speed, lead time, and deployment frequency, and process quality, mean time to restore, and change failure rate. I don't want to be making changes that break stuff in production. And unfortunately, within the commercial sector in the last few years, as a lot of companies have started to adopt Agile principles, they are going faster, but building up technical debt and breaking a lot more. So you really have to watch quality as you're going faster. And there are specific engineering principles that we're going to talk about here in a second that enable us to go fast forever, essentially, without that technical debt. We have engineering practices here called extreme programming. That's not Windows XP. And we'll talk about what these are. Pair programming, test-driven development, continuous integration, continuous deployment. So let's talk about those for a second. I'll work on it over here. So on any one of our software development teams, we have three main leadership roles that embody those three competencies we just talked about. A product manager whose job it is to move the needle on that value creation metric. If it is improving the workflow associated with the deliberate targeting process and reducing that workflow so that I can execute more targets, that's the one metric that matters. This PM's job is to monitor or prioritize work in a way that avoids cost of delay and achieves that value as fast as possible. The designer, we call this person the empathizer in chief. They have a very empathetic relationship with actual end users, and they are worried about ascertaining their users' pains and building capabilities that are going to address those pains. And then the engineering staff, the lead engineer, we call an anchor, has to address the equities of these two, right? So do the impossible of building value in a way that warfighters love. Build fast, don't build up tech debt, have cybersecurity built in, all of the above, right? So we draw this to mean that these three leadership positions are equals. The decision-making space is here, and all three of their equities have to be covered down. Because if we only focus on new feature creation, we will build up technical debt and fall flat on our face, so we can't do that. So addressing technical debt has to be part of prioritizing work. So it is a balanced team approach. And this team is practicing four main competencies. So the first one I'll talk about is pairing. And you can see as we show the rest of a typical 8-person team here, has 6 engineers where you have pairs, 3 pairs of engineers, one of them being the lead engineer, a product manager, and a designer. So why are engineers working in pairs? And what that looks like is, and you all would have seen it on the floor earlier, you have a workstation with 2 monitors. It's just 2 monitors, 2 keyboards, 2 mice, just 1 computer though, and only 1 engineer is writing code at any given time. The other one is watching the code. And every line of code starts as a discussion, an opportunity to think about the code that they're going to write. So studies have shown as we do pairing that, not just us, commercial industry studies have shown pair engineering allows upskilling of your engineering workforce very fluidly and quickly. So somebody new comes into the organization who has some new skills that the organization didn't have before. We rotate pairs on a daily basis. So within a week, that single engineer has worked with everybody on this team, and now everybody on the team has has those new skills, or at least been introduced to them. Similarly, we are able to achieve what's called shared context. So on a given application, everybody on that software development team, all the engineers, have context of all of the code base. All right, so they work in a very prioritized manner. If the product manager says the next most important thing to work on is a new user interface feature, that's the user story that the pair receives, that's what they work. If that happens to be fixing a cybersecurity vulnerability or doing a Java code upgrade, a COTS baseline upgrade, that's the engineering work that they'll do. So our user stories are broken down into about 2 to 4 hours worth of work, and those engineers have to become very good at doing the whole breadth of work, and they get access to and knowledge of the entire code baseline. So I no longer have Danny, the database guy, that if he gets hit by a bus or wins the lottery and doesn't show up tomorrow, the rest of us don't know anything about the database, right? Everybody learns that back-end stuff. And so the engineering workforce pairing is is able to upskill, onboard and offboard new members, knows the entire code base. Also, you end up with better quality code because you have two sets of eyes on the code as it's being generated. It's essentially full-time QA all the time. Also, because you have the ideas of two people going into every line of code, you write fewer lines of code. So it's kind of a tangent, but measuring lines of code is not a good thing to measure if you didn't know that. Unfortunately, the DoD is really stuck on it, but it hasn't been a good way of measuring software complexity for about 2 decades. And I do not want to incentivize code creation, so I do not measure lines of code. I want fewer lines of code. Code is a liability. I want the fewest lines of code possible to actually achieve the outcome I want with that software. So what do we focus on? One metric that matters, the outcome. That's what we need to measure. All right, so talk about pair programming, test-driven development, and I'll explain that as I'm explaining what continuous integration and continuous delivery are. So, as we get to a point where we have a user story, and this engineering pair is going to do 2 to 4 hours worth of engineering work. Let's say that in our application, we'll call it application A, we need to add a new feature. So the new feature is 2 to 4 hours worth of work for an engineering pair. The first thing that they're going to do to build this new feature is they're going to write an automated test that starts in a failing condition because the feature code they're about to write doesn't exist yet. So a user story will read something like this. Tad, the targeteer, needs to be able to go to X screen. And when they're on that screen, they need to hit drop-down menu Y. And drop-down menu should have these options. And if you select this option, you'll know it's successful when, blah, blah, blah. Okay, so that's a user story. They're written very user-focused or operationally oriented. The engineering pair probably also has a picture or a mock-up of what that feature should look like generated by the designer. So the product manager prioritized this work as the next most important thing. The designer provided a mock-up. The product manager also has devised this user story of the outcome they want to see on behalf of the user. So the engineering pair writes a test that is now failing because Tad the targeteer can't go click this button. Doesn't see the drop-down menu, can't select options. All of that is now an automated test. It's failing. Then they write the functional code that builds in that new function and that capability, and they only write the number of lines of code necessary to pass that test. This again is a disciplined approach that reduces the overall code base because they only write the code that's necessary to pass that test. Once the test is passed, the third thing this pair does is refactor the code. So look for opportunities to shrink down and make more efficient the code that they just wrote in the last 2 to 4 hours. Now I have very efficient code that provides this feature, and I have a test harness around it so that as I introduce it into the application, if anything ever impedes on the ability of that function of code to do what it's supposed to from every other software change that we're going to inject in the future, it'll break. The test will fail. So we have this feature that works in isolation. We put it in our continuous integration pipeline, and our pipelines, you would have seen them up on the TVs in the development floor. We'll talk more about this, but we're talking just about functional tests for now. We'll talk about cybersecurity tests in a minute. So I have this code that I need to check from a functional perspective. The new home of this feature, for just to depict it in a way that might be understandable, if this is the application and all the other features in that application, this is the new home of this new feature that we're writing, right? So I put this new feature out there. I know it works in isolation, but I have all of these other features. All of them also have test harnesses around them, right? Automated tests. Similarly, I have test around my interface to this other application. This is an application programming interface. API is a modern exchange, or again, an abstraction layer between my application and another application, or a database, or between my application and the underlying compute infrastructure, platform environment that's down here. So I have APIs. I can do code and unit level tests that verify all the other functions within an app. And where I have contracts from app to app, or app to database, or app to compute resource, I can automate the testing of those. So now I have an ability to make changes in my app independent of the support ecosystem around it. And I don't have to wait to update everything at once. So now I can have a product team that builds application A, independently releasing of product B, and they both have testable interfaces, and they will know if they would break a contract with each other, and they're able to update. And before pushing into production, their test would fail, and they would stop what they're doing and fix the test, right? So this way of working drastically improves our ability to work at speed, but have a repeatable test process in an automated way to ensure that when we're injecting change, we're not breaking anything. So this is continuous integration. So I don't want to work in isolation for a long time. A lot of traditional acquisition programs, when it comes to software development or IT system development, they'll give either to different development teams or different contractors big chunks of work and say, go work for 6 months and we'll integrate on the back end. So what happens, everybody goes off and does their thing. You've essentially forked a baseline, and now you're going to try to stick it back together. You end up with these problems we talked about earlier. All these integration points that aren't working at a big test, like a DT or OT event. So to avoid that, we do continuous integration. We don't want to be far removed from working shippable code. So it's only 2 to 4 hours worth of work. We inject this new code into the code baseline, and it is shippable, meaning we could put it in ops. And we know that it works. I don't want to have to debug after 6 months of work and 100,000 lines of code and have hundreds of IA or functional deficiencies. So if a problem ensues from a functional test perspective, this pair that just built this feature will know it was something they just did in the last couple hours that broke this system. So they can find it very easily, and then they make very small changes, right? So that is the practice of continuous integration, one of the fundamental aspects of extreme programming. Don't remove yourself far from having shippable code. So the code is sitting out here. For us, our development is hosted in AWS GovCloud, which means it's worldwide extensible. So any of our users can log into this development environment and check out new features as we're building them and give feedback on it. Because again, a lot of what we build the first time we get wrong in terms of creating user value. So we want an opportunity to iterate. And so our typical business cadence, while we can go through this process of building a line of code or a new feature, putting it in a development environment, and then again shipping it into an operational environment within an hour, we can do this. We typically, from a business cadence perspective, will only do it about weekly per team. And so we're building up 5 or 10 features or whatever it is and shipping at the end of the week. So continuous integration is important to ensure that I have shippable code. I'm getting user feedback, but continuous delivery is also important because this is a development environment, and while we try to make this almost exactly like the operational environment, until I marry this application to its actual databases, in which case many times are classified, I don't know for sure that it's going to work. So we want to continuously deliver and validate in operations what we've built. Again, build, measure, learn, and the highest degree of validation we can have is in ops. So continuous integration into a development environment. I can now push through a continuous delivery pipeline, which is essentially the same set of automated tests, into the intended operational environment. And I draw a logical separation down the same infrastructure and platform stack here to show that we first roll a new application instance. So if this becomes A prime because it has the new feature in it, I put A prime out here, nobody's using it yet, but I have it as a test, training, or staging environment on the same physical platform that current warfighting or operational use is ongoing with. So I have the previous version, A, I have A prime. Users are able to say, I like the new feature in A prime, put it in ops. And then it's just a logic flip to make this now A prime.
How do they do that? Is that, how do you receive that feedback from?
Yeah, so the feedback from end users, we have various different ways. A lot of times our teams are actually downrange with users ushering in new capabilities, or like we saw the VTCs earlier, we also use Mattermost, which is a capability, a social media capability that we set up discrete channels within Mattermost for each application, a support channel. So we're able to talk to end users, and if end users like what they see, they're providing feedback in there. If they don't like it or they have problems, they can also provide that feedback. We do phone calls. It's real time. We're getting feedback from end users. Our dev teams talk to actual end users every single day. That's critically important and stands in stark contrast to typical acquisitions where engineers go years without talking to end users. Right? So we're talking to the end users say, yay, verily, the new set of features is good. Make that the operational instance. And it's a easy logic flip where the next person to log in just logs into A prime and they don't know necessarily the difference other than they have new features. So we're able to make zero downtime updates to applications in this way. Similarly, our platform environment is just software-defined infrastructure. We treat it like an application. We have many COTS applications integrated into our PaaS environment. We would prefer to have as much of that be a commercially outsourced or commercially managed capability set as possible. And then we integrate those together in an automated way and maintain these platform environments at parity across multiple different classification levels, as I've talked about earlier, and several different geographically dispersed regions around the world to ensure that we have resiliency of our application availability and our data distributed across the world. So I'm running these platforms at parity across all these different locations so that as an application is built and I test that it works on the platform, I can now push it out to all these different, wherever it's needed, and know that it should work, right, with a high degree of confidence. So this process of extreme programming involves all of these disciplined approaches from an engineering perspective. This is how you are able to go fast and go fast repeatedly and not building up technical debt. I'll talk now about cybersecurity testing, right? So that's the other aspect. Yeah, go ahead.
Real quick, how do you manage or adjudicate user disagreements? And has your user community built a hierarchy or management of how they deal with that?
Yeah, very good question. So the question is around how do we adjudicate differences of opinions from a user perspective. I like the button green, no, I like it orange. That's the job primarily of the designer, who has to separate the wheat from the chaffs in terms of things that are nice to haves versus have to haves, and contextualizing then a lot of different disparate user groups, where if you will go to the AOC enterprise right now is like 22 different one-off systems that are all supposed to be the same. They're not the same because we've given them bad software, and so what you really have is 22 different calcified workarounds that are all needing to essentially come back to some doctrinal middle ground. So our software development teams highly inform themselves. I mentioned the designer's role is empathetic user research. A lot of that research is the requirements documents and doctrine So in some cases, they better understand than somebody who has only been a user, a 19-year-old user at a single AOC and knows one way, that is the calcified way that AOC does their job, which may not be doctrinally aligned. This person has a more holistic understanding of how the whole Air Force is supposed to be doing, or whole Joint Force is supposed to be doing this job. And then as they're getting feedback from different user groups, can figure out what is the more nominal implement that we should deliver. So, and there is a hierarchical receipt structure too that needs to be brought to bear. And this is maybe a complex tangent, but one we should probably have. So if I'm just delivering to the 609th, which was our starting point in Al Udeid, I have kind of a smaller user group. As we, but even then, within a particular division in the AOC, I may have tens or dozens of users. It's ultimately usually that chief, that division chief, who makes a determination on a weekly basis that the 10 features we built that week should become the next operational baseline. And we put it in ops. Now we're pushing the same product across multiple different AOCs. We're gaining feedback where we can and kind of making that decision to push into ops based on the greater good. Ultimately, though, what we have to get out of the habit of is a hierarchical decision structure that it has been based around fielding decisions. Fielding really should be a non-issue or a non-event. What we have to start gauging our hierarchical decision making around are deprecation decisions. So if I have new capabilities I'm putting in place today that are meant to replace a legacy system like the Theater Battle Management Core System Force Level, or TBMCS, the two systems are working in parallel. I started building very little capability, but I built something that obviates the need for the most painful part of using TBMCS today, or something that TBMCS just didn't do. And as I build more capability in the new modern software over time, users are adopting it for their workflow, so they might do steps 1 through 37 of their 100 steps in their workflow in the old system, and then they'll be using the new system for the rest of their workflow, right? Over time, then, they get to a point where they just don't need that legacy capability. And that's the point where we really need to have a big bang test event that is a functional fly-off that says, I now have a comprehensive set of capabilities I believe should be able to fully obviate the need for this legacy system. Does the test organization, the OT organization agree? And then the lead command should make that decision. We are turning off the legacy system, we don't need it anymore. I'll talk a little bit more about test in a while, but I think that was a good appetite whetter. Let me back up a little bit and talk about how a team starts this process, because we kind of jumped right in the middle of a feature build. If we back it up to going out and seeing tanker planners doing their aerial refuel planning on a whiteboard and not having, I'll get you in a second, not having any software, that's a stated problem, right? So Eric Schmidt, who was the chairman of the Defense Innovation Board, also used to be, the CEO at Google, was out at the 609th Combined Air Operations Center, walked around the floor, and Defense Innovation Unit was out there with the Defense Innovation Board and had in mind that they were going to build an app to do improve dynamic targeting. And Eric Schmidt saw these guys doing tanker planning on a whiteboard and said, "What is that?" And after a few minutes of them explaining how they plan out the refueling and how inefficient it is, he said, "This is your starting point. Fix this first. Don't worry about targeting." So that in and of itself was a prioritization of the work that we had to do to modernize an AOC. Rather than start on targeting problems, we're going to focus on tanker planning. So that kind of prioritization work is what embodies new frameworks called value stream mapping or impact mapping. If you haven't looked into those, you can learn about them in the 3 books I highlighted earlier, or read up on them, because this is the way that our lead commands, our requirement generating organizations, need to help us prioritize work, not within an application, but more at the portfolio level. Making that decision that says tanker planning is more important to work on right now than fixing targeting. And then essentially building a body of prioritized one-to-end problem sets that if I had another software team, I would put on that problem. So value stream and impact mapping, and then you have to baseline the current operational workflow. So if it's the targeting problem, I'll use planning out how we build an air tasking order. So I have to marry available assets to tasks that need to be completed. Fly mission X, and at 30 different bases I have fighters that could do this task, right? So I have to understand my friendly order of battle, what assets I have available, and the tasks that I need to do, and put them on a timeline. So we set out to build a capability to do that. The product name is Slapshot, and we stood up that team. They had to baseline the current workflow and understand how inefficient, or what is the current time it's taking to do a task on the ATO. And so they baseline that activity, and we say, well, we want to improve that workflow timeline by 40%. That, in essence, is what Air Combat Command can do for us in terms of requirements generation. It is an operational outcome that a team needs to achieve. Move the needle on this workflow by reducing the timeline 40%. That's the requirement. All right, so we stand up a team of nominally 8 people, but really we just start with usually the 3 leadership positions, maybe 4, because there's not enough defined engineering work yet to have a bunch of engineers sitting around. So we kick off this team and we give them the problem set of go fix the air tasking or air allocation problem set. Okay, what does that mean? So they're going to go do weeks of user interviews and user research. They're going to study the requirements documents. They're going to look at doctrine. More importantly, they're going to go out and talk to dozens of actual users who do this job on a daily basis to understand kind of the right and left boundaries of this workflow. And they don't define all of the steps and write a 100-page mission thread document to define it. They just really want to contextualize, understand the right and left boundaries of it, and narrow in. So we call this process discovery. We go wide and understand the right-left boundaries, and then we narrow in on a specific problem that is the most inefficient. Of the 100 steps in the proverbial workflow, step 67 happens to be the most inefficient. So I don't want to build a system to replace the 100 steps. I just want to build a capability that solves step 67 because it's very inefficient, or is error prone, or whatever the case may be. That is the metric that we're trying to change for that use case. The next phase of the activity is called framing, where again we remove ourselves from the defined workflow that user is used to and conceptualize new ways of solving their pain. So we go right and left in terms of understanding ways we might solve this, which might not involve new software. It could be retooling the workflow to eliminate some steps, or finding a COTS product that does the job, or finding some other government purpose rights software that does the job. Last resort is building new software. And let's say that's the case here. We have to build new software, so we narrow in on a potential solution set for that stated problem. And at this point, we essentially prioritize a list. We'll say this is the one-to-end feature list of a minimally viable product. This is a hypothesis at this point that if we produce feature sets one-to-end, we will solve this one problem in such a way that the user would choose to use our capability on day one because it would be more valuable to them than what they currently have. That's this point where we now have enough prioritized work to start coding. Up until this point, we may do some storyboards or clickable prototypes. We have some pretty cool COT software development tools that allow us to build mock-ups of what an application might look like, put it in front of users, let them click through how they would do their job, and it gives us a lot of feedback even before we invest any engineering resources into coding that capability. But that's the point we're at now. We're actually ready to start coding. That's inception. So that's where the team, or a pair, takes the next prioritized feature and builds in this manner. At first, we're not shipping into production. We have to build out the minimal set, which is probably more than a day's worth of work, right? So we want to get into production or into ops as fast as possible, because until we validate what we've built in operations, we are building up risk of building the wrong thing. But all the while, as we introduce new features, working down this list, we are getting feedback from users in our dev environment. They can access it from anywhere in the world. So we have a new capability that hasn't been in ops yet, but we are getting feedback on it. And if we learn something through feedback that invalidates one of the things we said we needed to build here, we change it. We're not locked in, right? So this is not a static requirements document. Don't think of it in that way. All right? Let's say, though, we now feel we have the minimal set of features and the users are telling us they actually like this thing. Then we put it out on a production environment. And again, it's here, so users, we can marry it to its potentially classified data set and verify that everything still works as intended. And then the users choose to adopt it or they don't. We don't force our products on anybody. They choose to adopt it because it makes their lives better. Just like you choose the apps you're going to use on your smartphone, right? That is the practice of user-centered design, where if it's not good enough, we didn't meet their need, we'll keep iterating until we meet the need. So build, measure, learn is that process of delivering an MVP. Sometimes we miss the mark. We thought we knew the features they needed, and we didn't get user adoption on day one. Sometimes we do, and sometimes we're very close, but just need a few more adjustments. So this particular use case of improving the task allocation process in the ATO cycle is a good example where the team worked. This process, by the way, from kickoff to inception is typically only 4 to 6 weeks. So again, contrast that to a process for AOC 10.2 that took 7 years till we even started generating anything, and then we never really delivered. But 4 to 6 weeks replaces this entire 7-year process. But again, I'm not trying to retire a whole AOC. I'm just solving one small problem. But it can be a very valuable problem. Remember the cost of delay, or $2.8 million a day. So I'm at this point. I built capability. I put it out there, and our team that was building this Slapshot tool went to the KAOC as they reached this point that they were ready to put it onto the SIPRnet. And they essentially ushered their capability onto the SIPRnet live with the users. The intended user group was the Combat Plans division that plans an air tasking order that assigns assets to a task, right? And so they put the capability on the SIPRnet, and they got a lot of feedback instantly. And the feedback loop was such that they iterated on that product, built new features, pushed it through into the SIPRnet, not yet operational, but in a staging environment. They did that 3 times a day for 3 days because they were getting so much rapid feedback. And on the 3rd day, they got user adoption by the whole Combat Plans division. Not only that, but the Combat Operations division, who in day of is executing the plan, used the same tool then for retasking. So that was kind of a first, that you have 2 divisions that were able to use the same tool for both planning and execution. And they went from 0 users to 120 users in 3 days. So we call this the first valuable iteration. If we don't hit the mark with the MVP, it's whenever we get user adoption. So again, you have 4 to 6 weeks for the DNF. It's usually about 2.5 or so months after that we release our MVPs, so maybe 4 months total. And then we're just iterating and gaining additional users. I'll give an example too. We intended to replace a legacy system for mission reporting. So every flight that goes, it doesn't matter what kind of flight it is, when you go and fly your mission, where it's a refueling mission, a mobility, a strike mission, an ISR mission, you come back, you got to generate a mission report. The legacy system for that had been out there for over a decade. It was breaking and probably unavailable more often than it was available. So they were writing mission reports into Microsoft Word and then having to fat finger them back into the system of record later. It was a crappy system, and users hated using it. So we built a new capability, and the way that we tackled this problem, and this is important from a lean product management perspective, is you start small user base, small use cases. We built misrep reporting for a single C-130 unit in AFCENT. All of the mission profile, unique stuff that had to be in a mission report for a C-130 only, in one unit. And then we grew to other units. We started doing misreps for F-16s and misreps for Reapers and misreps for other things. And within 11 months, we had built out a capability that was used for mission reports on all mission reports in AFCENT. And they retired the legacy system. So that's important to note when we think of complex systems that are used across multiple services, or even within the same service by disparate user groups. Again, it's lean product management, so I'm starting small with a very prioritized, most important thing I can work on. I'm going to grow that maturity later. I have the disciplined engineering approaches to allow a malleable software baseline that adds value and complexity over time, but I don't have to plan for or build up front all of that capability, because if I try to build it in isolation, I will get it wrong, it won't work, and it won't be valuable. We've seen the stats. Right? So this way of work allows where we're on a trajectory to retire TBMCS inside of the next 18 months or so across all the services, or we'll be able to afford them a comparable set of capabilities, and in many ways superior capabilities. But we start small. Right? We started only with the 609th KOC and then went to some of the other AOCs. So we went from the coined fight to the 613th, where they have the Pacific fight. We're working with the 603rd or the Yukon fight. Again, building out those different use cases and complexity and maturity into the software baseline over time. So the notion of, well, what percentage of the requirements are you done with? That's a hard thing to gauge. And you don't do requirement sell-off. This is why I'm shifting the conversation from fielding decisions and the test that would go into making those decisions to, in effect, I'm just developing the system, and at some point I'm going to choose to deprecate the old one. So the decisions we inform are deprecation decisions. That's where we got to think in the future. All right. Yeah, so, and I will talk more about security in a little bit. Let me build this out, because we talked through these 3 competencies. So this is that process I just went through. DNF, build, measure, learn, MVP, inception. We're able to do this on average in about 4 months. Internally, we did it in about 88 days, being our fastest. But recently, and this is one of the benefits of what we've built, where because we have this multi-region virtual private cloud infrastructure and platform as a service for all of our application teams, we now have an ability for external customers to use this as well. And so there was a team out at Space Missile Systems Center under an effort called Kobayashi Maru, Section 31, if you've heard of them. They were building a capability for space situational awareness that needed to go on the SIPRNet. And this is intended to replace another failed ACAT one called the JSPOC Mission System, or JMS. So They had a workflow that was similar to one of the products that we had. They just needed it to do something else that was space related. So they took our software baseline, which already had cybersecurity measures built into it, and had a functional workflow, essentially rebranded it, did some wickering on it, and put a valuable piece of software out on the SIPRnet and got user adoption in 57 days. So they went from no software to working software, creating value in 2 months. From a cybersecurity posture perspective, I'm glad you asked me to bring that back up. As we write a new feature or a line of code, we're able to push it through a CI pipeline. The CI pipeline has both functional testing aspects as well as cybersecurity. So we have a managed set of COTS cybersecurity tools. I've listed some of them here. This is not comprehensive. We do a lot of cybersecurity testing early and often. You would have seen on the 24 attributes of high-performing IT organizations, one of the first on that list of 8 for continuous delivery is shift left on security. So security is like one of the first things we're doing. Every new line of code, as soon as it gets written, goes into the CI pipeline. We're putting it through OWASP, Fortify, SonarQube, do a Java lint screening if it's a Java-based development effort. And then we have essentially an automated POAM repository called ThreadFix. So this is how, as we write our code, all of the other tools push to ThreadFix. These are the possible vulnerabilities. And then we have to identify what might be false positives, or if there is any high or medium vulnerability found by any of these tools, that line of code cannot pass through the pipeline. The pipeline shuts down. It is automated and it shuts it down. So now the pipeline goes red. In an automated way, the engineering pair gets an indication of where the problem is. They get a problem report from one of these tools. They'll fix it. So we write code that is very clean, both functionally and from a security posture perspective, every time we're writing code. And I drew it this way for simplicity's sake in terms of a feature's worth of code going through the pipeline. In actuality, it is the entirety of the code base going through this pipeline for functional and security checking every time we code commit, and we do this multiple times a day. So take Fortify scans, which are like the gold standard for ensuring that you don't have vulnerabilities, and then you put your RMF paperwork together, put it on an accrediting official's desk, and hope to God 12 months later he'll give you an accreditation to field your product, right? You do that Fortify scan, and then you have your static documentation that says my baseline's good. And then you get the accreditation and you field said baseline. That thing is now out in the wild in the system for a year or more before you build the next iteration and accredit it again, right? So all the while, the cybersecurity environment is changing, and there may be vulnerabilities you hadn't accounted for that the new version of Fortify would have flagged. So we're updating these COTS baselines all of the time and pushing all of our code through the pipeline multiple times a day. So if now something that is a vulnerability signature that shows up in the new version of Fortify that we didn't have in the system 2 weeks ago, we find out about it right away and we fix it that day. It's all of a sudden the next most important thing to do because my code won't commit. Right? So we now have really speed as the new security. I don't leave vulnerabilities in the field for 18 months at a time. Speed of our ability to detect and fix cybersecurity issues is the new security paradigm. So we have the same set of cybersecurity tools then in our development CI pipeline as well as our delivery pipelines. All right, so this is our process that's heavy on a lead command, like air combat command in our case. On the front end, this is where we come in and we do our thing to put out an MVP, and then on the back end, we're getting the user feedback that drives what we do next. All right, so I've talked a lot about this platform thing, and when you look at our organization, we're centered now around this thing that is now officially the Air Force C2 Common Platform. The Chief of Staff of the Air Force came out here and saw all the work that had gone into running infrastructure, running platform, building automated CI/CD tooling, the cybersecurity checks, the continuous authority to operate, really moving all of that pain away from empowered software development teams of 8 people. Said, why wouldn't we just have other programs use this capability of this platform? And in effect, that's what we had already done internally as an organization, where if I look from a capabilities perspective for operational command and control, AOC 10.1 and the now modernized version that we're building, Block 20, is using that platform. From an ISR and targeting perspective, you can see the other legacy systems that we're monitoring. Similarly, at unit level, fighter maintenance, scheduling, wing operations center capabilities. So the fighter maintenance scheduling, this is our F-35 Alice capabilities that we're building. Modeling and SIM, all able to use as a service this other capability. And then we started onboarding other customers. Joint Special Operations Command, PEO BES, if any of you have heard Bespin, their similar software factory organization, their first products were running on our platform. AFRL, Space and Missile Systems Center, the Kobayashi Maru I talked about. Air Mobility Command, taking the tanker planning capability that was theater-centric, and they have a global problem set, right, for air mobility. And then another F-35 team using our product as well. I think I have it on an upcoming chart. Somewhere in the neighborhood of about 40 product teams, about half of them are external to our organization riding on that platform. So from a platform perspective, our mantra is down here. Don't build when you can buy, and don't buy when you can rent. We want to use commercially managed solutions or products whenever possible, and move up the tech stack with commercially managed solutions as far as possible, so that we can focus on the value, which is the unique applications that we need to build and the associated data. So this is our problem set today in our legacy AOC 10.1 system. We own, from the bare metal up, the configuration management nightmare of building out the entirety of an AOC 10.1 system, and most of our resources goes to infrastructure and runtime environment. Very little on improving the actual mission applications our users care about. Contrast that with, if I'm able to use AWS GovCloud for this entire part of the stack, why not? In the case where we need on-premise cloud nodes, we use Dell VxRail, then we have a layer in between the underlying infrastructure and the application, so that the application doesn't know it's running an AWS or it's running on a vSphere implementation. It doesn't care. So we have this layer of abstraction in the middle. It's noted here as Pivotal Cloud Foundry. That was our starting point and is still in our baseline, but we've expanded the PaaS offering now. The runtime environment is all things: operating systems, domain name service, identity and access management. We've added additional services in there for like video services and mapping services. Anything that is commonly used across multiple applications, why have every one of those application teams have to build it uniquely? If it's a common service, we put it in the middle layer and provide it to everybody as a service. They can just plug into it with an API. So we're now running also Kubernetes clusters and can run a containerized orchestration model in addition to Pivotal Cloud Foundry. So we have choices, and we've grown out that capability. But again, it's leveraging the scale and our economies of scale that comes from commercially managed solutions, not trying to build the whole tech stack on our own. And so then what that affords is, again, I mentioned about 40 different product teams that you see them represented here as a software development team. It is a tall order for a team to be able to push a software application that they know works, that they know is cyber secure, and they know is going to work in several different environments worldwide. We abstract away as much of that problem set as we can. So you have a whole bunch of people and engineering competencies that go into providing the software development tools, the cybersecurity tools, the release engineering or the automation of our CI/CD pipelines, the engineering of the platform infrastructure, providing that abstraction from underlying infrastructure stacks, running the infrastructure stack if it's an on-premise vSphere implementation that we have to put in the field for resiliency or disconnected ops concerns. We're also building out edge compute capabilities. Within the next few months, we should have this where our platform will be miniaturized onto a briefcase-sized implementation, so we can put that shipboard, or we can put it, man-packable. Essentially, then you can use the same applications across AWS or Azure, an on-premise hardware stack that you have in an AOC, or something that is really at the tactical edge. And we're able to do that through building up all of these capabilities. There's people behind these capabilities. So you can see the kind of numbers that we involve here. Data science, another one. I will state here that right now there is an undue infatuation with machine learning, AI, and big data in the DoD. There is a lot of data out there in the Intel world, but in the command and control world, all of our data is in Microsoft Office products. It's not accessible for data analytics. So our starting point is building modern mission applications with data that we can actually exploit from an analytics perspective, and then we can think about ML AI, right? So we are building up these competencies. Right now, we have about 95 people involved in these different aspects to provide these services on all of these classification domains that we talked about before, SAP within the next couple of months, and 5 different geographic regions worldwide. That means that now I can just turn half a dozen people loose to build a new application, and they have all of this support structure to use. What does that look like in practice? This is really what it means to have built a software factory. It is, I have an ability to build a capability, to run that capability in ops, monitor it to make sure that it's running smoothly, and if something breaks, resolve it. So this is a continuous loop. This is DevOps. DevOps is not pairing developers with operators. If you've heard that, that's a misnomer. It's been misused within the DoD. DevOps is the marriage of development of a capability with IT operations, so that you are continuously delivering, monitoring, and running in production your capability. That is DevOps. So I mentioned before, I won't go into the details of our platform, but you can see we have either AWS, which we're using Dell VxRail, we have Pivotal Cloud Foundry, we also are running OpenShift implementation for Docker containers on Kubernetes and Heptio. And scaling then is also just as important in that, as what I just showed you is our enterprise services organization. We also have an acquisition organization that is building up the competencies to onboard additional third-party customers. So we have all of these technical enterprise services, those capabilities that we just talked about that we want to offer. We are gearing up on doing that from a enterprise contracts perspective and onboarding other customers. I won't belabor that here though. But ultimately, this is what we've already achieved across these different classifications that I've already talked about. We now have these on-premise vSphere implementations, as well as C2S on the high side, SC2S on CyberNet. We're gearing up on that as well. And then unclass production on AWS GovCloud. So test. I've already started talking quite a bit about test-driven development and how we are functionally and doing cybersecurity testing. But really the commercial best practices are to drive all functional equities, including test, including cybersecurity, onto empowered product teams closer to the problem. So they're solving or covering down on these equities that we would typically put at the end of development every day as we're building stuff, right? So everyone is now a tester. And we need to automate and invert the DoD's test pyramid. I'll show what that looks like here in a second. But really, we test drive the software so we know it's safe to change, and software is never done. We're always going to be changing it, so we want it test driven. Complex systems that work result from simple systems that work. That's Gall's law, and that really codifies the lean product approach that we take of essentially changing all the time. Automation and abstraction and building in test layers at those layers of abstraction is very important. So DoD testing practices typically miss the opportunity for ongoing test of whether we're building the right thing. Our focus is on building the right thing. What does that look like? This would be the typical DoD approach, which just by the nature of the DoD 5000, the first-time test organizations get an opportunity to bang away on the system, it is almost done, right? So we did that feasible, usable, useful pyramid. If now these bars represent weight of effort, I start here actually, and in code and unit level test, I do very little. If you look back on our legacy application baselines today, there is hardly any test automation, if any at all. And even component, where I'm going from one application to another, doing my end-to-end or integration tests. This is where DT and OT organizations focus, mostly manual test cards that are testing the end-to-end functionality of a system that's almost done. All right? Or doing exploratory testing to see what can be broken. So the commercial best practice for software is essentially what we already talked about over here. Start with the smallest piece of software and automate the crap out of everything as you're building it. So it inverts code and unit level test, my integrations from one app to the next, are major components within a system, and then end-to-end integrations where I might have 15 or 20 applications and associated databases building a comprehensive capability set. I can automate almost all of the testing associated with that so that one minute change I know will not break anything else. And so from a human test perspective, there is still a need. It's down here where you get to a point where automating tests just doesn't make sense anymore. Computers can't test everything. So a lot of exploratory testing, but now my humans, which are a low density, high demand asset, don't have to work solving problems or finding problems at the end that could have been solved here.
You had a lot, or to what extent have you had to deal with like the statutory requirements for independent operational and other testing? Because, you know, I'm part of the problem in a blue patch test organization. We are baselines from a world that doesn't apply to software, right? Mm-hmm. The vast majority of the money spent is going to be on production. Yeah. So there's this fiction that I make a decision on whether to spend the vast majority of, you know, funds in the future on software that's backwards, right? I've already spent all the money. How have you managed to communicate and solve that institutional roadblock?
Yeah, so I'll say we haven't solved the institutional roadblock of a test paradigm that is not optimized for this way of working. We are working on it, though. We have embedded with us in our organization over the last 8 months or so members from a couple different developmental test organizations, both on the cybersecurity side and the functional test side, 45th, 47th Test Squadron. We have embedded Aflotech as well from an operational test perspective. We are working with the process owners, if you will, of DOT&E, DT&E to cover down on their equities. And you remember I said earlier when we were talking about test, we're shifting the mindset from fielding decisions to deprecation decisions. And that's important because really the world I want to get to for test is periodic maturity assessments on our way to a deprecation decision. So as I'm building capabilities, or our teams are building capabilities on a daily basis, driven by what is the most important thing for the current warfight or the current ops tempo, we're not necessarily covering down on major combat ops scenarios. So what I want to do is, in parallel with continuous delivery and iteration, is have independent operational tests that take the form of like a red flag or blue flag exercise that is a big major combat ops test event, and now I have an opportunity for a maturity assessment that will guide my backlog. It will tell me where I need to improve product maturity. But the mindset is not pass-fail, because typically testers are looking at the black and white requirement document that was written a decade ago. Did you meet that requirement? I don't really care. Is it working? And if it's not as good as it needs to be, where do I need to improve? So it's a different mindset, because software is never done. I want a periodic assessment that is independent, telling me how else we can improve this baseline. And we're doing a lot of that now. I mean, we are in effect putting these processes in place, documenting them. We're iterating on, our temp, if you want to call it that, our test strategy that identifies a relationship between us and the developmental and operational test organizations, and how we have an ability to, as we did with continuous authority to operate, where we accredited a software development process, we have an ability to continuously deliver software, but we can't turn any old systems off until an independent test organization and the lead command says, yea, verily, we don't need that old system anymore.
Are you utilizing that process? You said you're utilizing it some today. So what is the balance between when we transition off of this archaic DTOT structure to this flexible structure, right? Somebody, higher headquarters authority is going to say, yeah, Kessel Run, you can do that. And DoD entities, weapon system programs, you can do that too.
Yeah.
Right now we're bound to a very, he runs the detachment, right? So
yeah,
we go through DT and OT in a very systematic, serial nature.
I said it here. Test community needs to upskill software coding competencies, and that's not a poke, right? This is just reality. So in my program office 2 years ago, we didn't have any software developers. Now we're almost all software developers, right? Not me, I'm not one of those, but this is a very automated and repeating in an automated way process now. So we have to change, and I think what you're getting at is, if you look at the organizational implications across the DoD between what has been a very siloed process of a program office or a contractor building a system, saying it's done, throwing it over to the fence to another organization to test it and say, yep, I agree, it's good for fielding, that has to change. So we are experimenting with what is this model where we shift left on all of these security and functional test competencies. We embed them on product teams so that the teams are doing that stuff. What is the right level of independence, if any, that we need at the developmental test level? And when it comes to operational test, I definitely see that as independent, but it is not a stage gate to operations anymore. It is merely that periodic maturity assessment, right? Yeah. So that's an evolving thing that we'll talk more offline about, I guess. I don't have a final answer. It's going to take a couple of years of really thinking through process, policy, and organizational construct, roles and responsibilities, changes that might ensue from achieving this way of work that is really the underpinning of high-performing IT organizations.
Is your goal to only affect Kessel Run's processes, though, or are you
No.
trying to get the Air Force to buy off on?
Not just the Air Force either. Yeah, so your question is am I just caring about Kessel Run? No. We, from day one, knew that what we were doing was ushering in a sea change that is going to fundamentally shift the entirety of the DoD. Right. And so wherever we are bumping into policy obstacles or culture obstacles, we highlight those as opportunities for change, not just for our sake, not just for the Air Force, but the whole DoD. That's why we have the DAU here. That's why when we embed Affotech, they're taking lessons learned and then informing the Agile test practices that are available in draft policy for the rest of the Air Force to use. We've invited DT&E and DOT&E to invite it into our processes as well, because we want to cover down on those equities, show that there is a different way that we can achieve a better outcome collectively, and then have that spread more across the DoD. Part of the reason why we're filming this today, right? So people can start thinking. We don't have all the answers, but cumulatively we know what doesn't work, and we're experimenting in ways that we think work. So let's broaden the aperture and get it right.
Because for folks like us, little weapon system program officers, it comes down to how we point to you and say, look, there's a new way of doing business, right?
Yeah.
And here's the authority.
Yeah.
Here's where we got this, because the first thing you're going to run into is a brick wall. You can't do that.
The culture. I'm getting to that slide.
Right.
All right. So agility within acquisition. So some of the folks here want to learn about the way that we've shifted on contracts, and we'll talk about that. These are the three systems that were on that horse blanket we saw earlier. The requirement system, JSIDS, the budgeting system, PPB&E, and the defense acquisition system. So from a requirements perspective, we talked about how lead commands like Air Combat Command can prioritize a backlog of work at the portfolio level with frameworks called value stream and impact mapping. On a PPB&E perspective, the mind shift has to change from widget-based in-state products and cost and schedule to get me there to an ever ongoing capacity utilization problem. It's level of effort. If I have another product team, I can tackle the next priority on the impact map that ACC gives me. If you cut funding from 5 teams, these are the 5 prioritized things that you just don't get, right? So level of effort and estimating our development capacity. So it's pretty easy when I look at a software development team of 8 people, which is a mix of military, government, civilian, and contractors, and I say, well, I know the cost of these 4 contractors or 5 contractors or however many I have. If I want 20 teams, I can figure out what the cost is. So development capacity is just a human concern, right, from a cost estimating perspective. And then I also have a cost of the underlying infrastructure, platform, COTS licensing products, and the number of people that have to run that as well. On the acquisition side, I'll talk about contracting in particular. We have gone to a modular contracting approach. Again, applying that concept of layers of abstraction or disaggregation. I have boundaries within my technical stack now that I can apply to the way that I think about hiring in specific competencies or acquiring different pieces of the tech stack. And we'll talk more about that. So on the acquisition entity perspective, right now we're executing primarily under India AFY 16 Section 804, which allows for rapid fielding, rapid prototyping, and rapid fielding. We have 6 different rapid fielding efforts right now that are now portfolio or capability-based concerns, different common operational capabilities that we need to provide. So I don't bucket by Joint Targeting Toolbox and AOC. I've broken that down into operational competencies and put those into acquisition entities. And then the underlying infrastructure platform CI/CD tooling that we talked about, we just providing as a service now, put that on the Air Force Investment Master List as a non-ACAT activity as well. But from a contracting mindset perspective, we are out of the business now of taking a CDD with 2,000 requirements in it and lobbying it to one contractor and saying, build me a whole AOC. I don't have to do that anymore. So no big, massive all-in-one contracts. I have separations of concern between CI/CD tooling, cybersecurity tools, infrastructure, platform, software development competency, software design competency, platform engineering competency, I can hire all of these competencies individually on several different contracts. It allows us to target specific competencies and get the best players who are probably small businesses that do that one thing very well, but would never have a hope of having all of the capability of building a whole AOC. We've tried that model of 4 or 5 companies in the world and say, go build me a whole AOC. They can't do that either. So we break the problem set down and target, from a contractual perspective, the competencies that we need. We've awarded a lot of contracts. This slide is actually out of date. I think in the last 18 months, we've awarded about 30 different contracts now. And we do so in an average of about 70 days. The Air Force Material Command average for contracts awards is about 335 days right now. And it doesn't matter whether it's a $5 million contract or $500 million contract. So because we're using other parts of the FAR, we're not doing those big bang contracts. We're doing primarily service-based contracts, some other transaction, but mostly FAR-based contracts. And again, geared around those specific competencies or capabilities that we need. So we're using a lot of FAR Part 8, 12, and 13, some 16, but that gives us an ability to kind of take a t-shirt size mentality to the problem set that we're trying to achieve in our contract and use different parts of the FAR where it makes most sense. So we have a lot of volume, a lot of contracts, and that's okay. I will mention here, OTA right now is kind of like the Bitcoin of contracting. Everybody thinks, oh, I should just do OTA for everything, and it's like this panacea. It is not. It is one tool in the toolbox that has a very specific use. We have used it. We do use it. But primarily, most of our contract awards are still FAR-based contracts. But we've been able to do those, open the door for a lot of small businesses that would have never been able to compete for our big build me an AOC $500 million contracts before. So what that looks like when you put it together, we have a government-led integration activity that is Kessel Run. We own all of the code. We own the technical baseline. And we hire in via service-based contracts the competencies that we need to help us build these capabilities. You can see the competencies or capabilities that we need here. Because I'm using different parts of the FAR, I keep my contract values very small. I'm disaggregating the complexity of an acquisition problem. This is why I can award contracts fast, because they very rarely go above my level for decision making. So they're all in-house, small dollar contracts. If I get a non-performer, it's an LOE or T&M contract, I just turn them off. I award another contract, or I have 5 different contracts for software development, right? We're about to award very soon. If one of those companies is not performing, I'll just ask them not to bring me any more bodies, and I'll go to the other companies, right? So this way disaggregates the risk involved in our acquisition and contracting. And you piece it together, all of these capabilities, you end up with a software factory that is churning out capability into ops every 11 hours or so.
Did you own your software baseline data rights at the start, or was there a transition?
The question is, do we own our data rights from the start, or is there a transition? From the legacy systems, it's a mix of both. Sometimes we don't, sometimes we do. So there are differing mechanisms, either contractually or from an engineering perspective, how we accommodate working around black boxes that we don't own. If we're able to plug into a defined interface, fine. This model doesn't preclude proprietary solutions. In fact, I mean, a lot of what we're pushing out, particularly on the infrastructure and platform side, are COTS products, of which some are proprietary licensed, right? I don't care to own those. I care to own the mission applications that we're building. But here, as long as I have a way to plug into that capability with an API and have a testable interface to it, I don't need to know what's in that black box.
I think maybe better offline. So
yeah, we can talk offline.
But the tools that you guys have, tools and techniques for managing a large pre-existing technical debt.
Yeah.
Both technically and administratively, and migrating that to the smaller.
Yeah.
It's got it differently, but not.
So it's worth highlighting here because I think most of the DoD is going to find this as well. There is a series of both qualitative and quantitative assessments that we need to go through as we go through the decision-making process of, if I have a legacy system, do I just refactor and reuse that code base? Do I throw it out the window and rebuild everything? I would prefer not to have to rebuild everything, but in almost every case we have done that. And not because we wanted to, but because it would actually take longer, cost more, and be more risky to try to refactor and rehost and reuse those legacy systems because they were built in a monolithic fashion without test automation. They're very fragile. You go in and start making changes, they break, and then you don't know what you did and you can't fix it. So one of the journeys we went on was with the legacy Joint Targeting Toolbox baseline. We re-platformed that legacy application, refactored the code baseline. We reduced it from about 1.5 million lines of code to about 700,000 lines of code without eliminating any functionality. The code was that bloated from a dead end code or circular code baseline, and that just highlights, like, we eventually gave up and said there's so much technical debt in this baseline. Even after we had replatformed it, we said there's so much technical debt here. To continue improving this capability, it'll just be easier to just start brand new. And so there's only been a few use cases that we've been able to brownfield or reuse some legacy capability, in which case you can apply all kinds of engineering practices to kind of put a test harness around a black box that is your old code, and then use this approach that we talked about for building tests around every new line of code that you build around that old black box. There's a lot of different opportunities there, but I think in general, the DoD is going to find the easiest way to build modern mission applications is greenfielding everything.
Can you explain a little more around the modular contracting and the services, use of services contracts in order to field software acquisitions?
Yeah, so the question was around explaining more about modular contracting and services-based acquisition. So back to this problem set of building a whole AOC. The traditional mindset says, I have a defined requirements document with 2,000 requirements. I have a program plan that some contractor should be able to do this in 3 years and $300 million, and I award a contract. I have a defined product-based contract that I'm holding them accountable to, right? In this way of work, remember, I'm working this way. I don't define an end state. I didn't even bother with 2,000 requirements. I just have a problem. And we know the issues, we saw them very early on in deterministic product-based work is you'll get it wrong, or you need to adapt and you're locked in. If I lock myself into a deterministic product contract that is 2,000 requirements and several years long, and the warfight is evolving and I'm learning.
What I mean is, how did you build the services contract?
Yeah.
How you understand the differences in processes.
Okay.
What I'm interested in, we have that archaic structure. We kick off a technology developmental contract.
Yeah.
And we go through that serial nature there.
Yep.
We have a CDD. We put it on contract, and the contractor develops it. How did you use the vehicle in a different way to make that happen?
So the services vehicles are inherent in those other parts of the FAR that I mentioned. They're more attuned to service-based contracting. Again, because I'm not deterministically determining what I'm going to build, I don't have any product-based contracts unless it's a COTS license, right? But in terms of building capability, I'm not hiring a contractor to build a capability. I'm hiring a contractor for the competency or skill that they bring. So I want a service-based contract, and I want to ensure that they have the right skill. So, for example, one of the ways that we approach that from a software developer contract perspective is we put out an RFP and said, explain to me, how you know what Agile development is, but I really don't care to read your paper. What I'm actually going to do is have you come in and we're going to do a paired coding challenge, and I have a problem and I want to watch your engineering pair from your company work on this problem and write code that is test automated and see that it works. And I spend half a day, and that's the test. And that's the most important factor in my contract award process is, does this company actually have the competency to do this work? Not can they write a good proposal and tell me they know how to do the work. I do not care about that. Right? So we have a lot of lessons learned that we've employed as we take these different competencies or capability areas that we need and segregate them into different contracts. We have a acquisition playbook that I'm happy to share with you that highlights a lot more detail than I have time to go into here. All right, so wrapping up here, what we deliver. User-centered design and lean product development equates to mission software built for Air Force and sister service needs. Continuous prioritize value creation as our products mature. We're not intending to retire any legacy systems on day one, nor may I get to sister services for a year or more. That's okay. Modern cloud-native web-based mission capabilities that now I can use accessible on multiple security classification levels and across multiple locations geographically. Source code as a service, it's all government owned, so if somebody else wants to take it and run it, they can. Or if they want to take it and fork it and use it for a different product like Space and Missile Systems Center did, they end up with working code in production in 2 months instead of burning additional engineering resources. We had good code that was test driven. They could modify it very easily because of that underlying test discipline in our code. Containerized applications, if you want to run containers, we can do that too. We have managed API services. So we have generated one of the problem sets within the Intel community is gaining access to the National Intelligence Database, MIDB. So we built an interface to MIDB. We can read write into MIDB, and now anybody that wants MIDB data can come to our data service, our event stream service called Ripsaw, and it has a modern API. So we offer that out. We have an event stream data architecture. I won't belabor the data side of things right now, but event stream is a modern form of pub-sub enterprise service bus, if you're familiar with that kind of old construct. So we use a Kafka event stream data architecture and continuing to grow that out. And now we have this C2 Common Platform. Right now it's Air Force only, just because the dollars invested in it, we can't service everybody. It is worldwide accessible from a development environment perspective. We have the ability now for continuous authority to operate, and can essentially anybody who builds on our pipelines, builds to our standards, can push with continuous authority to operate. We have that multi-region virtual private cloud that I mentioned, and it's available 24/7 ops. That was one of the reasons that we became a detachment, was because we are not just an acquisition activity anymore. The operational infrastructure and platform that mission applications doing real-world warfighting ops on is run by us, not a SIX. Typically, an ACOMS organization or part of the SIX would run the IT. We're running the IT. So we are both an acquiring organization and an operational organization. We had to be able to establish supporting relationships with operational combatant commanders. That it was part of the reason we became LCMC Det 12 with a G-Series order commander. So our value proposition relative to that common platform I mentioned is reduced cost, time, complexity, and risk of delivering mission value, like the Section 31 team that did it in 57 days. All right, so culture. This is going to be the biggest challenge that we all face. It's been the bane of my existence the last 2 years. People that are stuck in only knowing a way of work that unfortunately isn't working, and then not being open to thinking outside the box. Yes, there's fear. Yes, there's risk in change, but we have to think about how do we manage that risk and achieve better outcomes. You can see here from a cultural capabilities perspective, we strive here in our organization to have a generative culture, one that is valuing ideas and competency over rank and rigid ways of thinking. So we want transformational, open-minded or growth-minded people. Our workplace environment, you can see a relaxed dress code, that aircrew model. So I have often an E3 or E4 as a designer and a product manager being an O4. I don't want the rank involved in the natural tension that exists in informing the direction that product is going to go. It should be rankless in that regard. So small balanced teams. Having a workplace environment like you've seen here at Kessel Run also contributes to attracting and retaining talent. We're in a tech ecosystem here in Boston that has afforded us an ability to attract a lot of talent who wanted to do something different, who want to contribute to the national security of their country, but wouldn't do it at the expense of a 7-foot cube farm at Hanscom Air Force Base. Is what it is. So we have afforded that environment. We are growing from a talent perspective, and that allows us upskilling of our existent longer-term government, civilian, and military workforce as we bring in new blood, so to speak. Branding is an important thing. You see the Kessel Run around. When you walk into our software development organization, you'll see a lot of people wearing stuff like this. They really feel part of this entity that is Kessel Run. When we started, there was a tendency among senior leaders to want to say, oh, this is only AOC Pathfinder. We can't say that Kessel Run thing. Like, you're not getting the point. Like, the people that work here feel part of something that is important. They don't want to work for AOC Pathfinder. They want to work for Kessel Run. And branding is very important. We learned that from the commercial world as we went to companies like Allstate and HCSC. As they were remaking themselves, we saw that there too, that branding is very important. And it gives a sense of ownership to a digital transformation team. Compensation, we're still struggling with that. Honestly, on the government civilian side, there's only so much we've been able to do. I think concertedly the DoD has to do more. Looking at being closer to what the commercial sector affords, the competencies that we need to do the national security mission in software is going to require higher pay scales, bottom line. But we do know that people will give up some amount of pay to come here and work on a national security mission. There are great application builders out there that build apps that optimize your dog walking route so your dog can pee on grass, and I'm sure they pay a lot of money. But would you rather be a software developer developing that app or developing an app that helps your country defend itself better, right? So we have seen that from a monetary perspective, we can afford some lesser value because the mission and everything that we've built around Kessel Run does attract talent.
Besides this talent acquisition in physical environments, do you believe that some geographic separation from AFMC and the functional leadership is required?
So the question is around, do we feel that we need geographic separation from Air Force Material Command and the functional representation? I would say we're trying to change the mindset across all of the functional equities, because you've seen we have to cover down on those functional equities. It's not like we don't do them or we ignore them. We just do it in a different way. So all those functional equities have had to rebrand and relearn a different way of working. Most of them are good at doing that with us, right? And they're part of this organization. As we scaled, though, we started very small. Kessel Run started as less than 20 people, and now it's over 700 people. in 2 years, right? So as we continue to grow, and then as Dr. Roper says, well, I want one of those at PEO Best and I want one at SMC, we're following a pattern of scaling digital transformation that we aren't making up. If you read the startup way, big enterprises in the commercial industry have already done this. GE, Home Depot, Ford, HCSC, Allstate, there are a few others that we are mimicking a digital transformation pattern that we've seen with them, where you get senior leader buy-in, you have innovation activities that start at the bottom, and you squeeze the iron middle, right, or the frozen middle. And that's the process that has to ensue, not just within the Air Force, but across the other services and the intelligence community. I have the NRO coming here next month. I look forward to the ability to see this spread, but there is a pattern that we are mimicking that we've seen in commercial industry that does work. Starting small and scaling, and then it is a mitosis model where if I take people in mass, not like one person at a time that have been at Kessel Run, but I take a group of people that know this way of working and I put them somewhere else, like Montgomery, Alabama, all of a sudden they can start something called Bespin. Or I put some people out at SMC and they start Section 31 in Kobayashi Maru. Those folks are alumni of Kessel Run, many of them. And so that is a pattern that's been used in industry, and we're seeing it start to work within the Air Force. It can also be used across the DoD. The mitosis model, grow and divide and conquer some more, right?
That's an interesting perspective, because from an acquisition perspective, we're managed, like my career is managed by the program management functional.
Yeah.
Or if you're a financial manager, your career is managed by the financial management function.
I will say there is an opportunity, and LCMC leadership is heavily weighing this right now, where this is Air Force specific, so I'll be brief. We've gone too far down the road of functional alignment and beholdenness to functional equities. And we need to shift the pendulum back towards focusing collectively on operational outcomes, our warfighters. Because our acquisition community is stuck in the process of the defense acquisition process, not operational outcomes. And they're covering down on functional equities, not warfighter value. So that is another reason we have structured ourselves as a debt, because we are working to break some of that functional alignment mold from a command and control reporting structure relationship within the acquisition community, and it is much needed. Okay. With that, for you on the line, I appreciate your time, and I hope that was beneficial.